Okay, can you see my screen?
Yes, sir.
Okay. So we will start with the today's our topic, that is safety aspects in electric vehicles. And also there is one more topic on standards for charging stations in India as well as in global scenario. So first we will cover this safety aspects in electric vehicle. So as we know that these electric vehicles represent a complete different technology compared with internal combustion engines. So this means that new safety hazards will come, mainly related to the characteristics of high power electric equipment is always get to be present, right? So the electric vehicle system shall be designed to operate safely in all conditions. A number of specific problems will be treated. So concentrating on the aspects of the vehicle behavior, which are typical for electric vehicles, at this moment, the standards and the official regulations concerning the electric road vehicles are not very clearly defined. The existing documents and standards are far from the harmonized, and they cover vehicle in full technological evolution. So the another aspect is the psychological awareness of this new risk. The presence of high voltage or of battery chemicals may use as an argument against the electric vehicles. The fact that internal combustion engine vehicles present large risk too is often overlooked. People having get used to be a danger for that. So in urban traffic, due to their behavior, due to their beneficial effect on environment, electric vehicles are an important factor for improvement of traffic and more particularly for a healthier living environment. The electric vehicle represent a new technology introducing electric power components on board road vehicles. The different risks associated with this technology must be carefully assessed. The risk levels, however, should not be overestimated by fear of the unknown. So there are different aspects of electric safety can be considered on electric vehicles, like electric system safety, functional safety, then battery charging safety, vehicle maintenance, operation, and training. So what are the basic standards of electric vehicles from the safety point of view? So the safety landscape is vast, but products are a good place to start. So for example, the lithium batteries and the high voltages used in the electric vehicles have high energy density and non-flammable electrolyte. Hence, the safety standards includes the testing mechanical integrity, resistance to mechanical shock, and resistance during operation, and when the vehicle is parked. Like most modern products, EVs are subject to electromagnetic compliance test, that is EMC testing. This covers in-car electronics such as GPS, TTC heaters, Bluetooth, keyless entry, immobilizers, as well as other key safety components such as airbags, ABS, anti-locking braking systems, and etc. So also from safety point of view, a special product feature in Japan is issued nowadays, which is in the issue of noise. EVs are quiet, so which makes it difficult to hear them approaching the person. So that can be dangerous for visually impaired people. To resolve this issue, the Ministry of the Land, Infrastructure and Transport has set up a guidelines that required EVs to have an alarm and generate some same noise volume as conventional combustion engine car generates. So these are the some a few standards and factors are involving in recent technology and as per the behavior of the EVs in today's scenario. So globally, the safety standards of electric vehicles. So globally, safety standards are marked as follows. So first one is the unintended vehicle movement. So unwanted movement of the vehicle, we can say. So in that, a warning is given to the
Hello, sir.
driver with hello.
Sir, your screen is not
Yes.
visible. Okay, okay, it is.
Yeah.
Uh,
It is visible now.
Yes, yes, Harshal, it is visible. You just need to, all participants need to ping the presentation which Harshal sir is showing. Then you will not feel, you will not have any issue related to looking at the presentation. You're audible and it is clear, sir. You can go ahead. Yeah.
Okay. So it is not lagging, right? My voice is also properly audible.
Yes.
Okay, fine. Okay. So unintended vehicle movement. So we can call as a unwanted movement of the vehicle. A warning in this, a warning is given to the driver when the car is initially switched to active driving possibility mode. If the car is still in active driving possibility mode, alert the driver before the starting it. The direction of the car's driver is indicated to the driver. So external charging prevents the movement from the vehicle's propulsion system. Then the second one is the shock protection. So shock protection, the protection against the direct contact. So what is there in the direct contact? So physical barriers or access protection. So physical barriers or access protection in the sense the person who is directly in contact with the body of the vehicle may get a sudden shock from the high voltage battery packs. So that has to be avoided. Then the marking. The marking is the enclosures, electrical protection barriers, and color coding of high voltage wires or cables. And signs has to be initialized in the while implementing the high voltage wire harness within the vehicle architecture, and that indication will recognize the driver or user that which are the hazardous impacts from where we have to keep aside from the these particular components. Then protection against indirect contact. So indirect contact in the sense minimum isolation resistance, then fuel cell isolation resistance monitoring, then isolation resistance for charging coupling system, and protection against the water effects. So whenever indirect contact, if rainy season is there, if you are charging your vehicle, so in that time it may get your charger may get in contact with the water supply, and it may hazard your charger as well as it may harm a direct shock to the user. So these all isolation and resistance to the battery pack as well as whole EV architecture, even for the user, those who are handling this has to be protected well. So for this, we have to conduct a charge standards, and there are specific standards has to be gone through. Then only your vehicle will get properly validated. Then third one is the elimination, mitigation, or potential thermal or explosive events. So as you can see, there are a lot of events happening in two-wheelers, moped vehicles, like fire catching events during the summer season when the temperature goes up above a certain temperature, beyond the certain temperature in Pune. In summer season, we can see in 40 degree, above 40 degrees Celsius, most of the mopeds causes this fire catching events. So outside temperature is 40, but the ambient temperature inside the battery compartment, it must be obviously higher. So the thermal stability of that particular cell should not go beyond that. So for that, you have to make your electronic system so compatible with BMS that it should handle the complete battery pack. It should not sustain the thermal stability. It should management as well as there should be a proper packaging. There should be proper mechanical handling of this battery pack, and charging contactors should be provided for these battery packs. So in this, what tests are involved? In this, vibration tests are involved. That is, component testing is done. If it is a battery, then it is a vibration testing within the vehicle. Then thermal shock and cycling components testing is done. Then fire resistance. So it is the material which is used for that particular EV vehicle or battery pack. It should be completely fire resistance, even though if there is an external short circuit or any fire catching events happen, so it should not catch the fire, and it should protect the battery pack from the sudden danger explosion. So there are some features of overcharging protection, over discharge protection, then over temperature protection, over current protection, low temperature protection. So all these features are monitored and diagnosed properly by the help of battery management system. So that has to be taken purely by the OEMs. So BMS is the playing the main role in these features, because BMS has to monitor, it has to balance, and it has to properly estimate the state of charge of the complete battery pack. So all these features has to be properly validated and standardized as per the ARI standard cycle. Then fourth one is the rechargeable energy storage system, installation integrity and protection. So in that it comes the restricts the mounting location for impact protection. So where the center of gravity, how the elements and components has to be properly implemented within the EV architecture, that has to be properly restricted. Then the place or shielded from the contact with the debris. Then it should remain attached with not to enter the passenger compartment. So there should be no any extra wirings or any extra harmful barrier should come within the passenger compartment, or it may get some damage during the traveling or some luggage or compartments and all. And there should be a proper place for the chassis distribution for battery placement management, energy management, so that battery will be completely in stable position and it will get a proper thermal management capability. Then fifth one is the rechargeable energy storage system, or we can say the rupture resistance and toxic gas management. So in that it comes with the mechanical shock, mechanical integrity, electrolyte leakage. So if we consider rechargeable energy storage systems, so it's obviously a battery pack. So completely battery pack is the main core focus in compare with conventional vehicle use engine. So in this, the battery packs, traction battery packs makes more sense for driving the complete EV. So mechanical shock testing has to be done. It should not have any penetration, or drop test are tremendously done. It should be completely covered. The casing should be completely robust and tough. And there are certain drop tests are done. Batteries fall down from the 1 meter of height. That time it should sustain and it should not break down. The internal structure should be mechanically integrated properly. All the BMS, all the wirings, all the battery tracking, all the spot welding done for the battery packaging, it should sustain properly. There should be a proper thermal heat shield and proper what we say, the cell holder should be integrated properly to hold within the battery pack. So all that integrity with the BMS, wire harness, mechanical coverage, casing and all has to be properly integrated. Then the electrolyte leakage. So while battery pack generation or assembly, we need to uh, properly survey the each and every cells, so that it should not having any defect with the cells, or it should not having any leakage with the electrolyte. If we know if any electrolyte is leakage is there, after a certain time, after vibrations, the electrolyte may get exhausted, and due to that the anode and cathode may get in contact, and there will be a short circuit, and that short circuit may cause hazardous for whole other battery packs. So all this rechargeable energy storage system, this testing has to be done precisely. Then next one is the low energy stranding. So driving warning of the low rechargeable energy storage system energy. Then BMS for the battery management system, GPS tracking, then low energy signs. So low energy stranding means, in the sense, SOC estimation. If the user is driving the vehicle, electric vehicles, most important is the range anicity. So if he is driving the vehicle, he should get the exact prediction of the vehicle range. He should be aware about the how many kilometers the range exactly your vehicles will go as per the driving cycle, and after how many cycles he has to charge the battery. So all that BMS functionality, all that algorithm, or what we say real time GPS tracking, low energy science, has to be completely completely shown on the cluster of the vehicle. so that the user will get that completely awareness of the vehicle management. So next is the Indian safety standards of electric vehicles. So currently, what are the Indian safety standards involved in electric vehicles? So electric vehicles have the potential to offer many benefits to the society, such as improved air quality in towns and cities, reduce carbon dioxide emissions from the road transport, that is depending on the source of the electricity we are using. Then, however, they are very different from conventional vehicles and present some new safety hazards. Clearly, electric vehicles are not inherently unsafe, nor will they necessarily expose the public to greater risk than internal combustion engine vehicles. Nevertheless, there is always the potential for unintended consequences whenever a new technology is introduced, right? So if such consequences are to be minimized, then it is important that the vehicle safety regulations keep pace with the new technology. So some basic electrical vehicle safety requirements are as follow. That is the occupant protection from the electric shock, then the charging requirements, then next is the safety requirements for the rechargeable energy storage system. Then fourth one is the electrical isolation, battery integrity, then best practices or guidelines for the manufacturers or the emergency responders, then battery discharge procedure, etc. So all these aspects and all these steps has to be followed, and complete user awareness has to be given to the customers, so that the OEMs will implement this all features within their vehicles, and a user will not found any issues with their riding safely with their electric vehicles. So as we already discussed, that the occupant protection from the electric shock, so it should be shock proof. Your vehicle should not get caused from the electric shocks, high voltage electric shocks during charging or while driving the vehicle. There should be a charging requirement. Charging requirements in the sense it should be available. Charging port should be available. Accessibility should be available on your single phase supply also. Even though you are using on the home supply that is 15 amperes or 32 amperes, then it should be able to charge. Then the safety requirement for the rechargeable energy storage, that we already discussed about the batteries, battery placements, integrity, its electrical mechanical stability, and its battery discharge processes, and what has to be done when the battery goes into the discharge mode. So all this has to be properly implemented by the OEMs, so that the users will not find any difficulties during their safe riding of the electric vehicle. Then the electrical safety in use. So the voltages used in electric vehicles are potentially very dangerous. However, a range of safety features are typically used to ensure the safety of the occupants or other persons. Crucially, the high voltage circuit is isolated from the vehicle chassis and any other conductors. So in fact, the ground fault monitoring system will detect any leakage of the current and will disconnect the high voltage system from the rechargeable energy storage system. Then the safety requirements for electrical powertrains are set out in the UN Regulation 100, that is 2019. It compromises the specification and test procedures in four main areas. So what are these four main areas? That is protection against electric shock, rechargeable energy storage system, functional safety, and determination of hydrogen emissions. So hydrogen emissions is the main concern when we are using for the hybrid vehicles, because hybrid vehicles are concerned with the electric as well as combustion energy systems. So we need to reduce the hydrogen emissions, and we need to make the environment free riding with the electric vehicles. Then electrical safety before the post crash. So a collision should compromise the electrical safety measures described in the previous section and could increase the risk of the electric shock. So for example, the electric isolation might be lost such that both the positive and negative sides of the circuit come into contact with the vehicle bodywork, if any of the occupant touch the bodywork, they would become a part of the high voltage circuit and would receive an electric shock. So to minimize the effect, following things are done. So what are the things has to be done in order to protect the user from a sudden shock from the high voltage circuit? That is, the placement of the battery in secure position has to be always checked by the OEMs, and it has to be tested properly. Then numerous electric motors place is not in contact with to the passenger seat. So electric motors place in non-contact area to the passenger seat has to be properly diagnosis. Electric wiring are isolated with minimum 4 layers of isolation. So cables which are using for the wire harness, wiring of the electric components, that should be at least 4 layers should be there for this isolation. It should not get the due to the higher voltage and current within that wiring. It should not get easily burn out. It should be not. It should be fire retardant. Then the sign and indicator are provided to secure and loss of electric power. So all the signs, whatever indicators are, signs and indicators are there, has to be properly securely provided within the electric power system, so that the user will get awareness about the following a step back from that component. Then the emergency switches and fuses are has to be provided for any emergency situation. So if your driving habits, or if you are driving with the autopilot vehicles and it is it is not in your control, so there should be a emergency switches. Or if your battery is overcharging or over discharging, so that time there should be some fuses has to be protected to get the battery pack in the normal mode. Then I will show you one video regarding, before moving further with the in detail with the electric safety. So everything you need to know about the safety of the electric vehicles. So this is the video you need to see in detail, which will clarify your doubts in electric vehicles safety and as compared to IC engine. Yeah, I think there is some issue with the playing with the video.
Sir, if you have a link, you can post it into another tab and then share the tab. Share that tab. So the video will be.
Let me check once again.
If you copy the link and share, post it in another tab and then share the tab, that is also fine. Yes, now it is okay.
No, still it is not opening. Just a minute, I will check in another app.
Are you still using Excel to manage your inventory? And losing hours and
Hello friends, welcome. to EV quotient.
Okay, can you see now?
Yes, sir.
Okay.
Podcast series. Today we are going to talk about the safety of electric vehicles.
Audio is comfortable?
Everything you need to know about the safety of an
Yes,
electric
sir.
vehicle.
Yes, sir.
Sounds interesting, right? You may have a million queries in mind about the safety of an electric vehicle. Hopefully, by the end of this podcast, you will have most of the answers. Electric vehicle safety is enhanced by technological advancements as well as stringent regulations which are enforced globally and in India. We have divided the discussion into three parts: crash safety, fire safety, and electrical shock safety. Let's start off with crash safety. Crash safety can be further subdivided into two parts. One is active safety and another one is passive safety. Active safety are features which prevents accidents. With EVs, the number of accidents are low because of the following reasons. Point A. In an electric vehicle, the battery is the heaviest component. And since batteries are placed beneath the floor, center of gravity of an EV is lower than petrol or a diesel car. It serves as an inbuilt safety system and makes EV quite stable while driving as well as cargo. Point B. In EVs, the ability to control torque at each of the wheels is far more precise. This helps to reduce tire slippages and hence the number of accidents. Point C. Electric vehicles are heavier than conventional petrol and diesel cars, which leads to higher kinetic energy. That's a problem. This challenge is addressed by tuning the active safety features like ABS, which is anti-lock braking system, and ESP, which is electronic stability program, to suit the requirement. Point D. Weight distribution of electric vehicle is nearly uniform across the front and rear axles compared to heavier front axle load on petrol cars. This helps EV to remain stable during hard braking. Now let's move on to passive safety. Passive safety features help save the occupants after the accident. Electric vehicles go through similar crash safety tests like an internal combustion engine cars, such as frontal crash, side impact, and rear crash. The most important EV component which needs to be protected in the event of a crash is battery box. Different OEMs address this issue differently. For example, Polestar, the brand owned by Volvo Cars, have designed a SPOC block. They call it as spoke block, specifically designed to minimize the intrusion of the wheel, tire, and other object towards the battery pack in the event of a collision. Whereas Tesla have securely encased the battery box in a crash-proof steel casing that can withstand front, side, and rear impacts. This reduces the damage to battery components and hence avoids spillages and fire. In addition to the above, absence of a heavy mass like engine in the front improves functional crumple zone of the electric vehicle. This helps to avoid rupture of the firewall into the passenger compartment, improving the safety of the occupant. Moving on to the second part, which is fire safety. This topic is split into two subtopics. First one is preventing fire hazard and then post-fire safety. Preventing fire hazard. Electric vehicles are safer than ICE cars due to the lower flammability of lithium-ion batteries. In addition to this, improved battery chemistry plays a key role. Battery cells have separators between anode and cathode. These separators are coated with select inorganic materials to enhance the thermal, mechanical, and electrochemical performances of the battery. Cooling. Most automakers have shifted to liquid cooling technologies to keep the temperature of the battery, water, and power electronics in a safe operating temperature range. And finally, the tests and validations. Batteries undergo the following abusive tests to ensure they are safe from any fire hazard: electrical short circuit test, fire resistance test, radiant heat test, mechanical crush, and battery drop test. Because of these reasons, the probability of an EV catching fire is lower than internal combustion engine cars. According to an analysis carried out by an US agency from a database of 60,000 crashes, fire was found in 4.4% of IC engine cars, as against only 2.6% of EVs. Post-fire safety. In case of an unfortunate fire accident, gasoline fire starts almost immediately and spreads rapidly, whereas electric vehicle battery fire typically takes some time to achieve the heat necessary to start the fire. That delay can let the occupants of an EV to get out of the vehicle in time. Tesla provides an extra aluminum plate for fire protection between the battery pack and passenger compartment. Though not mandatory, it helps to keep the vehicle safe, isn't it? Leading automakers including Toyota, Tesla, Volkswagen, BYD, and BMW are investing heavily in developing next generation solid state battery technology that should lead to more safer batteries. Hope you are feeling a lot safer now. Can we now deep dive into our last part, which is electrical shock safety? Electric vehicles operate at a very high voltage compared to petrol or diesel cars. ICE cars run on a 12-volt battery system, whereas electric vehicles operate at a voltage band of 400 to 800 volts. To ensure safe operation and handling of electric vehicles, the high voltage cables and connectors are protected with multiple layers of shield and insulation. I'm now going to take you on a tour of different scenarios you might face while driving. In the event of flooding, the electrical components in an EV are well protected to avoid dust and water ingress. The regulatory standard which ensures ingress protection is called the IP standard. IP stands for ingress protection. Electric vehicles need to clear IP67 certifications before they can be sold in open market. IP67 protects electric vehicle components from dust and water ingress up to 1 meter depth. OEMs do extensive validation, including water wading tests, to ensure IP compliance. You would have seen Nexon EV, which is from Tata stable, undergoing water wading test in a couple of YouTube videos. The next scenario is in the event of damage. Electric vehicle batteries are connected to the motor through a secure connector. This connector is switched on or off via a pyrofuse attached to the battery box. This pyrofuse helps isolate battery box from rest of the vehicle during an accident. This way, both the occupants and rescuers remain safe from an electric shock post-accident. Pyrofuse is a semiconductor device which blows out the cable connection to the high voltage battery by means of a miniature explosion, thereby quickly and effectively shutting off the power circulation. This way, pyrofuse eliminates the risk of electrical shock or fire post-accident. The last scenario is the charging safety. Charging cables and the charging stations are waterproof and are fully insulated from any electric shock. Plus, features like undercharge and overcharge protections adds to the safety. Charging connectors also come with a theft-proof lock mechanism, which prevents anyone from disconnecting the cable from a vehicle while charging. On that note, we come to an end of this podcast. It's truly electrifying, right? Hope you found it useful. We would love to hear from you.
So hopefully you got some idea about the how the standards and what are the safety requirements related to electric vehicles, right? Okay. So moving towards the next slide now, that is the ARI standards and regulations for electric vehicles in India. So ARI, the body ARI handles these standards for electric vehicles as well as for conventional combustion vehicles. So India has the fourth largest automobile industry in the world. The industry is expanding with a compound annual growth rate of 7%. Worldwide, the transportation sector is responsible for 24% of all CO2 emissions from the fuel combustion. Three quarters are from the road transport. India relies on imports from the approximately 81.7% of its crude oil requirements and ranks third in the terms of energy consumption after the USA and China. It is as per the energy policy in India. So based on this prediction, India's reliance on oil imports will continue to rise, right? So which will result in a surge in the price of oil and natural gas. So EV penetration levels, EV policies, charging infrastructure, battery cost and electrification, EV efficiency, and government initiatives have been identified as the indicators of the growth and development of the EV market is in India. So the government of India has collaborated with the several agencies to provide the flexibility to the industries, including AVs, working towards this innovative ecosystem. The Department of Science and Technology, that is DST, cooperated with the Department of Heavy Industry, DHI, to create the technological platform for electric mobility STEAM. So ARI stands for Automobile Research Association of India. So this committee, this body handles the overall EV architecture standards as well as for IC engine standards, hybrid vehicle standards, regulations and testings. So what is ARI and what is its importance for EV in India? So Automotive Research Association of India, that is also known as ARI, was established in 1966. It is the leading automotive research and development organization of India, set up by automotive industry with the government of India. So ARI is an autonomous body affiliated with the Ministry of Heavy Industries, Government of India. It has been playing a crucial role in assuring safe, less polluting, more efficient and reliable vehicles, and has been recognized as a scientific and industrial research organization by many government departments. So furthermore, ARI is one of the prime testing and certification agencies notified by Government of India under the Rule 126 of Central Motor Vehicle Rules in 1989. ARI vision is to become a world-class mobility engineering, research and innovation institution and leading a global automotive certification, testing and evaluation organization. Its mission is to create and facilitate a safe, sustainable and smart mobility solutions. So ARI pledges a support to all stakeholders within its motto that progress through the research. So the automotive sector has always been an paramount importance for the country's growth, and ARI has been playing a dynamic role in the progress of this Indian automotive sector, working in harmony and confidence with its stakeholders. For example, the government industry for the development of automotive industry, etc. They are developing the indigenous chargers for the electric vehicles to give a push to the electric vehicles ecosystem in India to promote the electric vehicles infrastructure for charging, and it's important. And currently, mobility chargers are imported to the India. So ARI is focused on developing these indigenous chargers because these chargers are cost effective and will help to boost the local economy and to get more charging infrastructure created within the country. So ARI helps to perform the following function for the electric vehicles. So what are the functions are conducted by the ARI to perform well electric vehicles? So first one is the battery performance and safety testing is done. Then electric motor characterization, then vehicle performance and homologation as per the center motor vehicle regulations on chassis dynamometer and test tracks. Then charger testing and certification is done. Electric vehicle development, rechargeable energy storage system evolution and using by CAE software. Then four-poster durability of electric vehicle in climatic chamber for structural adequacy testing. So all these functions has to be clarified, and it has to be sustained by OEMs as well as for the startups to get their vehicle launch. And once this all these following functions are properly sustainable, then only we can they will approve the vehicle that it's properly approved as per these standards. Then ARI standards for electric vehicles and chargers, which are as follows. So you must be aware about the standards which are in the perspective of chargers, battery, energy storage systems. Then IP67 is there, waterproof testings and all mechanical testings are involved. So in detail, we are going to learn about the standards which are included. So ARI has set some standards for electric vehicles and chargers, which are as follow. That is, first one is the AIS 038, which is for the electric powertrain vehicle construction and functional safety requirements. So it includes the requirement of vehicle with regards to specific requirement for the electric powertrain and requirements of vehicle rechargeable electrical energy storage system, and concerning is safety. Then AIS 039, so electric powertrain vehicles measurement of electrical energy consumptions. So this standard helps in measuring the consumption of electric energy by the electric vehicles. Then the AIS 40, the electric powertrain vehicles method of measuring the range. So this standard is used for measuring the range of the vehicle. So it is a range test for the electric vehicles. Then next one is the AIS 041. It is also for electric powertrain vehicles, which is used for the measurement of net power and the maximum 30 minutes of power consumption and utilization. So it helps in the measurement of the net power of the electric vehicle, and it explains the working and benefits of the maximum 30 minutes of power. Then AIS 049. 049 is for the center motor vehicle regulations type approval for electric powertrain vehicles. So it is a test of gradability for electric vehicles. So ARI is committed to developing a sustainable mobility solutions for a safer, sustainable, and cleaner environment and transportation sector. So it is committed to leveraging all its resources to protect the interest of its customers, stakeholders, employees, and overall operations. So they have a trained people, technology, and tools to fulfill their commitments. This is the well-equipped to take a future challenges. They are an important element of an growth of the automotive sector in India. So you can see this link I had put here link. So in this, all the standards are given. So if I go to these standards, this website, you can see the EV standards, testing and evaluation standards for EV and hybrid electric vehicles. So one by one, if you see, there is a revision 1 for 038, 039, 040, 041. So all AIS 156 that we will discuss in next slide. So if I open one of the slide, one of the standard. So this is the AIS 038 standard. So it was, so what it represents, Center Motor Test for Technical Standing Committee. So set up by Ministry of Road Transport and Highways. So this is the automotive industry standard for electric powertrain vehicles. Construction and functional safety requirements. So while construction and functional safety requirements, what are the standards and testing procedures and test cases has to be done during the implementation of electric vehicles. So you can read this in your free time about the specification of the test, what are the protection against direct contacts of the part, isolation resistance measurement, confirmation method for functions of onboard isolation resistance monitoring systems. So protection against electric shock, protection against direct current contact with the body of the vehicle, what kind of a contactor should be placed, then service disconnect, then markings, what are the markings and signs and symbols has to be involved. So as per this, protection against indirect contact, isolation resistance, so all this in detail has to be compiled by the OEMs for validation of their EV vehicles. Even not only for electric vehicles, you can see the fuel cell cars also has been nominated here. What are the standards and what compatibility should be there? So as per these standards requirements, the EV will get validated and it will get launched. It will get approved by the ARI standards. So you can see this in details within this website. I had already put the link in this PPT. So in free time, you can check all the requirements of each and every standards. Then coming towards the electric vehicle standards and regulations in India. So globally, the automotive industry is passing through a paradigmatic shift. The past century has been the era of internal combustion engine, primarily an account of an ease of use, availability, and low cost of fossil fuels. The shift to electric mobility has become necessary on an account of the fast depletion of fossil fuels, rapid increase in energy cost, impact of transportation on the environment, and concerns over the climatic changes. Right? So, why are the standards and regulation required for the EVs? So, EVs are gaining more popularity in the marketplace. Hence, the OEMs are obliged to ensure the safety of the public. With the increase in the use of electric scooters and electric cars, it will need ease of use for the customers. Robust testing and certification can help to meet both the above mentioned objectives. Some of the other reasons for standardizations are social demand, minimum safety requirements, performance requirement, quality during the product life cycle, technical technological advancement, access to global markets, standardization is governed by various government agencies. Then CMVR, that is the Central Motor Vehicle Rules, is a technical standard committee. AISC is the Automotive Indian Standard Committee, Standing Committee on the Emission Legislation, Bureau of Indian Standards, that is BIS. So testing of various components in an electric vehicle must be done for its role in the application, reliability, durability, safety, efficiency, etc. So you can see this picture. These are all the ERI ecosystem equipments validation testing is done. So in these hardware in loop systems, each and every vehicle is tested for its crash testing, for its dynamic testing, for its water resistance testing, anti-braking side skating testing. So everything has to be properly tested as per the rules and regulations and standards provided by the AIs. So type of approval testing under Central Motor Vehicle Regulations. So you can see, so type of approval testing under Central Vehicle Regulations are, vehicle rules are, first one is the verification. then safety and performance. So under verification, it is a functional verification, then construction, lighting and signaling, windscreen and wiping. This verification is done. Then the safety, in safety is this electric shock, water effects, rechargeable energy storage system safety, then crash and after crash safety. In performance, the range of the vehicle, how much energy is consumption is done for that to achieve the particular range of the vehicle, at what particular drive cycle, at what particular speed, then how much power consumption is needed, how much time is needed for charging the vehicle, how much discharge time is needed, then maximum speed can be achieved by that particular vehicle, and then the braking system working on that up to that speed. So all this standard approval testing has to be done under the central motor vehicle rules for the verification, safety and performance categories. Then the category and the type of approval required for EVs in India. So what are the category and type of approval is required for EVs to get launched in India? So if you are going to launch your electric vehicle and or retrofitted vehicles, so there are some standards and categories to get approved from ARI. Unless and until you cannot get launch or ride that vehicle within the Indian roads. So no central motor vehicle rules certification is required for vehicles falling the specification with 250 watt. That is the 30 minutes power of motor of a maximum speed achieving 25 kilometer per hour. So, however, such vehicles need to comply with the following things. That is the white reflectors on the front side, red reflectors on the rear side, brakes. A vehicle without a battery must weigh below 60 kg. So if the certification which is not needed, the vehicles should not exceed more than 250 watt of motor, and it should not have a speed maximum limit of 25 kilometer per hour. So if this certain criteria is matched, then only you can launch your vehicle on the road. And in this category, it falls with the electric bicycles or portable
Harshal,
electric scooters.
Harshal,
Yes.
sorry to interrupt you in between, because I want to ask one question regarding this point.
Okay.
So this particular ratings which you are shown, that the vehicle must be traveling less than 25 kilometer per hour, and the should have only 250 watt as of capacity. So
Yes.
anything which is above this rating requires ARI approval, and anything which is below this or below this doesn't require ARI certification. Is it the same thing?
Yes. You are right, sir. Anything which is going beyond the 25 kilometer and beyond the 250 watt of motor consumption, then for that ARI approval has to be is needed. So you can see the moped vehicle, those who are having 45 kilometer of speed range or 60. So all that has to be got certification and standardization verification has to be done by ARI. But with this category, having the maximum speed of 25 with 250 of power consumption. So for this, there is no certain verification or standard is needed. There is no, we don't have to put any approval charges for this. We can launch any kind of our prototype or vehicle on road. Only the things they had mentioned that you have to put the white reflectors on the front side, then red reflectors on the rear side, then braking should be properly done, and vehicle without a battery should not go above 60 kg. The whatever particular vehicle,
anything which is below this rating comes under the category of cycle or bicycle, right?
Bicycle, or you can say right now I'm using the portable electric scooter, which is foldable. So all these equipments falls into this category.
Okay, got it, sir. Thank you.
Then the government regulation framework for electric vehicles. So some of the global regulations are rolled out by SCE, AIS, by Central Motor Vehicle Regulations and UN ECE regulations, R100, R101, R85 for electric vehicles. Then AI standards for electric vehicles in India. Some of the regulations are AIS 038, AIS 39, 40, 41, 48, and 49. As we already discussed, AIS 38 is the requirement for construction and functional safety. Then 39 is the measurement for electrical energy consumptions, that is watt-hour per kilometer. Then AIS 40 is the method for measuring the range. Then AIS 41 is the measurement for net power and maximum 30 minutes of power consumptions. Then AIS 49 is for Central Motor Vehicle rules type approval for electric vehicles. And most important, the AIS 048, that is the safety requirements for the traction batteries. So these 48 standard specifically decides the battery functionality, traction batteries standards, its functional capability in aspects of its penetration testing, crack testing, then falling into the thermal stability testing, drop test, overcharge, over discharge testing, external short circuit testing, vibration, drop test. So a lot of things are involved in these traction batteries development and verification. Then for L category of vehicles, that is two-wheeler and three-wheelers, the criteria is the standard is AIS 156 in line with UN R36, covers the following points. So what are these standards? What are the tests carried out with AIS 156? So as we discussed that vibration test. So this safety requirement AIS 156 is the safety requirement with respect to EV and rechargeable electrical energy storage system for L category of vehicles. L category vehicles which falls into two-wheelers and three-wheelers. So in that, vibration test is the first one, thermal shock and cycling test, mechanical drop test for renewable energy storage systems, then mechanical shock test, fire resistant testing, external shock circuit protection, overcharge protection, over discharge protection, over temperature protection. This all has to be covered with that particular L category vehicles, two-wheelers and three-wheelers. So you can also go through this AIS 156 standards in briefly. You will get an idea of how the standards and how the tests are carried out. So what are the frequently asked questions by the customers and by the OEMs? So what are the ARI certification and why it is important? So many of the socially they are not OEMs, those who are setting, they are startups or those who are into this EV ecosystem, they are not aware about the ARI certifications and all. So what is ARI certification and why it is very important? So ARI certifications are authorized for the testing and certification of vehicles and engines used for the both automotive and non-automotive applications. So they play a vital role in ensuring safer, less polluting, more efficient and more reliable vehicles. So they carry out a sponsor R&D projects with the help of Government of India. Okay, then what is the homologation of the vehicles? In ARI it is done. So homologation of electric vehicle, it is the process of certifying that a particular vehicle is roadworthy and matches the certain specified criteria laid out by the government for all e-vehicles made out or imported into that particular country. So even though you are importing any particular EV vehicle, so it has to go with a certain homologation testing within the ARI compliances, and it should govern the proper certification from that, and you should have the approval to drive into the Indian road conditions. Then ARI approval process for an electric scooters. So what are the process for an electric scooter? So as we discussed, the electric vehicles with the maximum power of fewer than 250 watts and speed less than 25 kilometer per hour are expected from the type are exempted from the type from this approval of the requirements. So there is no need to get approval for this kind of a criteria limit. So you should check if your vehicle falls under this limit. If yes, then you should approach ARI for necessary relaxation. If the vehicle is above these limits, it will be treated as a motor vehicle and hence will need to be a type approval. Then ARI approval and testing cost in India. So ARI test cost will depend on the vehicle category and its technical specification. One has to apply for approval by giving detailed vehicle specification in the required format. Details about the formats are available on the ARI websites. On the receipts of the application, ARI calculates the test fees. So ARI testing procedure. So ARI approval and testing cost, it depends on the what kind of specification you are going to present in ARI certification. So if your vehicle is either two-wheeler or four-wheeler, or whether it is a high voltage bus system, so all that details, pre-details has to be given to the ARI authority, and based on that they will give the total costing of particular vehicle testing. So depending on the number of voltage of the battery, higher rating of the battery, or higher speed range of the vehicle, the approval and testing cost of ARI will differ. Then ARI testing procedure for electric vehicles. So compliance testing and certification requires at least 2 or 3 months for each new vehicle model. So this type of approval is done according to the vehicle model. The test is defined by in the commercial motor vehicle rules, and details regarding that type of approval applications are available on the ARI websites. So these are some of the curious things about the ARI, and what are the approval processes, testing, certifications, and procedure for electric vehicles has to be taken into consideration. So as we discuss the standards which I mentioned, these standards are very valuable and very important while testing into the R&D section. So these standards, if you go in brief, you will get more idea about the testing, how the testing is done for electric vehicles, what are the mandatory things, what things has to be taken into mind for road safety, for functional safety, and for getting proper performance. That is standards for charging stations in India and globally. So it's 4 o'clock. Should we take 5 minutes?
Yes, sir, you can take a break if you want, because in the morning also you engage for 2 hours.
Yes, yes. So I will take only 5 minutes of break and I will get back.
Yes, sir.
Okay, can you see my screen?
Yes, sir.
So standards for electric vehicles, we just discussed in previous session. So what were the electric vehicles architecture standards, and how the verification validations, what these standards has to be gone through, that we discuss. Now there are specific standards for electric vehicles charging stations. So charging infrastructure, energy storage systems, all this comes under this criteria in India as well as in globally. So in this session, we are going to discuss about the types of electric vehicle charging stations, its charging methods, connector guns, modes of charging, and testing and certification standards, and current status of Indian standards with respect to international standards. Also, we are going to study the key challenges in the standardization of EV charging systems worldwide and provides the recommendation. So it is recommended to use the combined charging system, that is called as a CCS charging methodology, which will cater the electric vehicle market in the country as well as abroad and help to promote the faster adoption of EVs. So with many advantages with combined charging systems, that is CCS, charging methodologies such as single connector, both AC and DC charging, high power capacity promoted by a large number of EV manufacturers across the globe, etc. It is recommended to use CCS charging methodology. Then Charge the Moon, that is CHAdeMO, is the only charging methodology having a vehicle to grid, that is V2G functionality, that can be made compatible with local grid codes, which can support the grid during the peak load demand using the combination of bidirectional electric vehicle charging systems and EV batteries acting as an energy storage equipment. And finally, comparative analysis is provided between the Indian standards and international standards for Europe, China, Japan, Germany, North America, and International Organization for Standardization. So we will discuss about the global scenario. So as we know, the electric vehicles and their charging stations are already a reality in India, and it is going to transform the entire transportation sector soon. Some of the existing EVs presently running on the Indian roads are Mahindra E2O, Reva, Ather Bikes, Ola, Tata Nexons, and few others. The main reason driving the Indian
Hello.
Hello, what happened, Shukumar?
Sir, actually, you went mute a minute ago.
Okay, from where?
No, sir, you just started international standards and then you went mute. Hardly a minute ago.
Okay, so I explained the abstraction about this regarding the combined charging methodology and all, vehicle to grid.
So could you please explain the slide?
Okay, I will explain it.
Yeah, we heard that vehicle to grid, but
Okay.
as soon as the slide changed,
Okay, I will explain once again. Now, can you see my slide?
yes, sir.
Okay, so from abstraction, I will go. So in this session, we are going to discuss about the types of electric vehicles, vehicle charging systems, then its charging methods, connector guns, modes of charging and testing and certification standards, then current status of Indian standards with respect to international standards. Also, we are going to study the key challenges in standardization of electric vehicle charging stations worldwide and provides the recommendations for it. It is recommended to use the combined charging systems charging methodology, which will cater the electric vehicles market in the country as well as abroad, and will help to promote the faster adoption of EVs. With many advantages with this CCS uh, charging combined charging system methodology, such as a single connector methodology, will single connector, both AC to DC charging, high power capacity, promoted by the large number of EV manufacturers across the globe, etc. So it is recommended to use CCS charging methodology. Charge the Move, that is a CHAdeMO, is the only charging methodology having a vehicle to grid functionality that can be made compatible with local grid codes, which can support the grid during peak load demand using the combine of bidirectional electric vehicle charging systems and EV batteries acting as an energy storage equipment. So finally, we are going to comparatively analyze provided between the Indian standards and international standards from Europe, China, Japan, Germany, North America, and International Organization for Standardization, that is ISO. Then moving towards the global scenario, as we know, the electric vehicles and their charging stations are already a reality in India, and it is going to transform the entire transportation sector soon. Some of the existing EVs presently running on the Indian road are Reva, Mahindra ETO, Ether Bikes, Ola, and Nexon EVs, and few others. The main reason driving the Indian automobile sector are energy security for reducing the fuel import and dependency on other countries. Then climatical change goals, air pollution reduction, which is the mainly CO2 emissions and industrial competitiveness. As a matter of fact, EVs were commercialized before internal combustion engines. So IC engines were invented in the year 1860 and commercialized in the year 1900. But the EV's invention was in the year 1827, which is 33 years earlier than the invention year of IC engines, and was commercialized in the year 1839, which is having a time gap of 12 years. So between invention and commercialization, according to the International Energy Agency, the total number of EV sales globally reached 30 lakhs by 2017, with more than 50% of sale is from China. Almost 40% of EVs are registered in Norway during the year 2017, followed by Iceland with 11.7% and Sweden with 6.3%. In line with the Paris Agreement on climate change control and reduction in carbon dioxide emission in the automobile sector, an ambitious target of 22.8 crores of EVs will be on road by the year 2030. So these EVs require the presence of EV chargers in the place on the roads before the EVs for the convenience in charging EV batteries, which influences the significantly the adaptation rate of EVs and their utilization. So as we know, there are two classes of charging, that is the slow charging and fast charging. The typical slow charging, also called as a AC charging, which is used in homes and public places with the power ratings less than 22 kilowatt. 22 kilowatt is used across Europe and India. The different slow charging stations have a power rating such as 3.3 kilowatt, 7 kilowatt, 11 kilowatt, 15 kilowatt, 19 kilowatt, and 22 kilowatt, which is predominantly it is used in the US. Also recently, Tesla company has introduced the highest capacity of AC charging stations for charging their EV batteries in short time. That is the Tesla AC charger, which has the capacity of 43 kilowatt, and it is a slow charging. So various countries, including India, have come up with the several schemes, policies, and subsidies to promote the adaptation of EVs globally. Some of the countries that are major players in the e-mobility sector, like China, Norway, United States, United Kingdom, Japan, Iceland, and Sweden. So in this all, China is leading the e-mobility sector, with an expected 70 lakh of EVs by the end of the year 2025. And China presently has more than 27,000 charging stations for EVs and 800 battery swapping stations. So next in line is the Norway, having more than 4 lakhs of EVs and hybrid EVs registered and 16,000 of charging stations as of 2020. To encourage the adoption of EVs, the United States has designed a government policies and granted a tax credits and subsidies at the state level since 2009. So California was the first state to fund 41% of rupees to promote the use of zero emission vehicles. In the UK, the EVs and hybrid EVs are eligible for 100% discount on London congestion chargers since the February 2015. The purchase incentives on EVs, including the installation of home chargers, were provided by the UK government for both private and business sectors to promote the use of EVs. Also, the distribution companies in the United Kingdoms are not allowed to operate or own charging stations or use them as an energy storage equipment. So Japan has introduced the use of zero emission vehicles by launching the Clean Energy Vehicles program in year 1998, which provides the incentives and tax exemptions. The Tokyo government had provided 10 crores yen for the manufacturing and R&D for the establishment of charging stations and support to the manufacturer zero emission vehicles. So despite in the COVID-19 pandemic and drop in the global sales of EVs by 16%, by the end of year 2021 and 22, there are 1 crore of EVs in the world, which is 41% higher than the EVs in the year 2010. So with the Europe as the world largest EV market in 2021, overtaking China for the first time, about 30 lakhs of EVs were sold globally, which is approximately 4.6% of sales share. E-buses and e-trucks registrations also were increased, with more than 20% in the transport segment. The two and three wheelers are the most electrified as they can be done easily because of the lightweight and fewer issues related to the charging from the grid. For an EV to increase globally, the access to the charge the battery is important factor for EV customers, and their convenience, the advancement in the technology for charging stations, government policies, city plannings, transport mode, travel patterns, and distribution companies will play an important role in deciding the type of charger and location of the charging stations. So, three major types of charging station based on location are home charging, workplace charging, and public charging. Home charging is the most preferable for EV customers who live in apartments
Excuse
or
me,
have, yeah.
sir. Whatever you are saying is present on your slide or what?
No, all the
Because
points are not presented in the slide.
no, because we could only see global scenario slide from so many
Yeah,
time.
yeah, yeah. That slide only I'm presenting right now.
Okay, sir. Okay, no issues.
Okay, so home charging is the most preferable for EV customers who live in apartments or have the access to parking. Workplace charging will depend on the employer-based initiatives and regional policies. Public charging stations are usually put in place where the home and workplace charging facility demands are insufficient. So it is estimated that the private charging stations will account for 90% of all the chargers by 2030, out of which 70% are slow charging compared to the fast charging. The electricity demand from EVs contributes around 1% of the worldwide electricity consumption. The demand is expected to increase by to 2% by 2030. The EV sector is expected to impact significantly on the power system by increasing the peak power generation and transmission capacity, as well as intelligent charging is essential to ensure the grid stability. And then moving towards the Indian scenario. So The first scheme with the respect to EVs by the Indian government was launched in 2013. The National Electric Mobility Mission Plan, that is NEMMP. The main aim of NEMMP is to provide support for promoting EV technologies, that is demand incentives, manufacturing incentives, development of charging stations, and research. The incentives were for reaching out an ambitious goal of 50 to 70 lakhs, which is approximately 14% to 16% EV penetration in sales of new electric and hybrid vehicles by 2020. The scheme grants a rebate of 7,500 to 22,000 from 62 eligible models from 11 original equipment manufacturers, OEMs of India. So in 2015, the faster adoption and manufacturing of EV vehicles in India, that is the FAME scheme, was launched to realize the objective set by NEMMP. So this scheme was active for 3 years with an outlay of rupees 795 crores, covering all vehicle segments and all forms of hybrid and battery EVs. So this scheme has approved pilot projects for 390 electric buses, that is e-buses, 370 electric taxis, 720 electric autos, and charging stations worth 40 crores in across 11 states of India. But before the FAME scheme, in the year 2009 to 2010, the Ministry of New and Renewable Energy initiated the scheme to incentivize the EVs. In this scheme, the incentives up to 20% were provided, which led to surge in sales of EVs initially and came to an end, that is 65% of sales was declined after the scheme came to an end. So Delhi state government has provided up to 29.5% of the cost in terms of tax rebates. Other incentives like tax concessions on EVs for manufacturers were promoted on excise duty, countervailing the duty, and exemption from the basic custom duties. Later, in 2019 to 20 year, India announced the second phase of FAME scheme, that is called as a FAME 2. So this scheme is for 3 year duration with an investment of 10,000 crores for 16 lakhs of EVs. Apart from the incentives, additional fiscal and non-fiscal incentives like green license plates, permit free, no registration fee, income tax reduction on loans taken for procuring EVs, custom duty exemptions, tax reduction on EVs to 5%, and no road tax were provided. So these differences in the taxation is a key incentive for EVs. And this scheme reduces the purchase price of the hybrid and EVs with a focus on the vehicles used for the public or shared transportation like buses and rickshaws and taxis and private two-wheelers. India has currently 30 lakhs of battery electric vehicles consisting of 23.8 lakhs of electric three-wheelers, 6 lakhs of electric two-wheelers, and 0.1 lakhs of the cars. So the Indian EV market is dominated by e-three-wheelers that is used highly in cities and towns for commutation, and electric two-wheelers compromises only 3 to 4% of high-speed vehicles, that is more than 25 km per hour. So the Indian government expects e-mobility will completely take over the transportation sector by 2050. All Indian state government are already in the process of finalizing their policies and regulations for EV adaptations to meet the target of FAME 2. So 6 states, that is Andhra Pradesh, Kerala, Karnataka, Maharashtra, Uttarakhand, Uttar Pradesh, Delhi, and Telangana have published their EV policies. Other indirect schemes like National Smart Grid Mission, that is NSGM, and the 500 gigawatt renewable energy target by 2030 are some of the primary drivers of grid modernization and distributed generation. For achieving India's large target for EV adaptation by 2030, electricity supply for EVs must be in the place before the EVs come to the road. Advertising, technological advancement, and the execution of both EVs and energy vehicle charging stations must happen in parallel with the installation of EV charging systems. So slightly before the EVs to allow the far faster adoption. Due to the less awareness among the public in India, the need for electric vehicle charging station installation must take the lead for EV adaptation at faster rate. So electric vehicle charging stations are going to be installed in a very large number across the country, and they will be connected to the utility grid for its input power supply. This will make challenges in the terms of grid handling capacity, distribution system upgrades, the impact of transformer loading, degradation of components, location of installation, pattern of load consumption, time of uses, etc. Therefore, it is very important to test and check the quality of energy vehicle charging stations which will be manufactured and installed to tackle all the challenges by evaluation of energy vehicle charging station based on relevant national and international standards. So in this session, detailed information is provided on the testing and evaluation standards, both national and international standards for energy vehicles charging station adopted by India with respect to other countries, considering the global scenario, the importance of this testing standards for electric vehicle charging station will ensure its working performance and reliability. So although the standardization for charging has come a long way and publicly accessible infrastructures have been made available in several countries, the standardization process is not yet completed and several issues remain open. So this session aims to highlight the current activities in this area on global and Indian level. Also, in detail, I am investigating the types of charging methodologies, connector guns, testing standards, and compare the Indian standards with global standards of the energy vehicle charging systems. And therefore, it is required to understand its definition, which is provided in the further slides. So before moving further, let me explain that what exactly energy vehicles charging station is. So it is an equipment that provides electrical energy to the electric vehicle battery for its recharging purpose using intelligent communication and protection technology to ensure the safe flow of electricity. So electric vehicle charging stations are also called as a EV supply equipments, EV recharge point, or EV chargers, etc. Then the EV market segment, that is the EV market segment in Indian scenario. So EV, electric vehicles and electric vehicle charging stations are related to each other, and one cannot exist without the other, right? So apart from the requirement of electric vehicle charging stations, we need to understand the present automobile sector in India. As of April 2020, there are around 64 OEMs and 112 EV manufacturers across the globe in India. So there are total of 17 EV component manufacturers. So as you can see in the figure, shows the current EV segment, market segment in India. The EV category can be classified into 4 groups, that is two-wheeler, three-wheeler, passenger vehicles, and commercial vehicles. So in case of electric vehicle charging stations manufactured in India, there are only 8 companies, that is Athergrid, that is BHEL, SBD Green Energy and Infra, Exicom, Delta Electronics, Mastech, ABB, EVQ Point, Bright Blue, Magenta Group, and RRT Electropower. So all the manufacturers of India are manufacturing combined charging system type AC and DC chargers, that is AC 001 chargers and DC 001 chargers, to supply to both the Indian market and the global market. Due to the sheer size of this prospective market in India, more starters for EVs and EV charging stations are expected to come up in the future. To cater large need of EV and EV charging system in the future, quality control through the testing the products as per the relevant standards is must to ensure the performance and reliability of the components used in the manufacturing. Then the types of electric vehicle charging stations and what are the future trends. So to understand broader view of the charging standards, a better understanding of existing charging types in the world. So there are many types of electric vehicle charging stations present in the world and can be classified mainly into two groups. That is conductive or wired charging, conductive or wire charging, or non-conductive or wireless charging, or it is also called as a inductive charging. So the conductive charging market is greater than the non-conductive type of charging, as it is present in all parts of the world and highly commercialized. Under conductive charging system, which are using a cable for power transfer. Further classification on electric vehicle charging station can be done in 6 groups, that is location of use, output base, input base, mounting structure base, based on electric shock and environmental condition. Other types of conductive charging are pantograph based charging and battery swapping based charging. The charging system which can be automized are the battery swapping system, wireless charging system, and pantograph based charging, where no human contact with charging cable is required. The battery swapping system, BSS, uses the robotic arm to move out the battery from the EV and replace it with the fully charged battery. So this process does not involve going to EV charging system to charge the EV, and these charging stations are called as a battery swapping stations. So this process takes less than time and can be operated easily by hand for fewer weight batteries, as in the case for two-wheelers and three-wheelers and mopeds. So with a large market for two-wheeler and three-wheeler in India, this could be an ideal way of promoting the adaptation of EVs at faster pace among the public, as it is also easy to create the battery swapping systems. The pantograph charging systems uses a conductive component in between the EV and the charging system, but it is usually located at the top of the vehicle. So this type of charging delivers high power in a short period, and it is generally for the heavy duty buses, trucks, especially for the vehicles used in the harbors and airports. So there are two different types of pantograph based charging, that is rooftop pantograph, that is mounted on the top or rooftop of the EV, and inverted pantograph attached to the charging infrastructure. So the wireless charging infrastructure charging system does not use any means of cable or conductive component in between electric vehicle charging and EV during the process of charging the EV. The process of charging wirelessly happens through induction pads, where the charging stations will have a transmitting reinforcement, that is RF pad, above the which the EV will be stationed and receive the reinforcement transmission through a receiving RF pad inside the EV at the bottom. So the power is transferred inductively from the transmitting RF pad to receiving RF pad, and then through the battery management system and to the battery. So lastly, all the possible types of charging systems are now being converted to the smart charging systems, which use the tools such as intelligent softwares, artificial intelligence, the Internet of Things, mobile app based, etc., grid to vehicle charging processes based on the energy availability, considering the off peak and peak load conditions of the grid, is considered as a smart charging. So similarly, the vehicle to grid charging process, which is used to pump the electricity back into the grid during the peak times or high energy need times by making the optimal use of EV batteries, can be another example of smart charging. So classification of electric vehicle charging systems. So in this slide, figure shows the complete picture of the classification of on electric vehicle charging systems. So based on the output of electric vehicle charging system, it can be classified as AC or DC electric vehicle charging system, which are having 3 categories of voltage level, that is low voltage, that is LV, less than 120 volt, medium voltage, less than 500 volt and high voltage greater than 500 volt. Similarly, in case of the input side of electric vehicle charging system, there are three possible types of inputs, which are grid supply, renewable energy storage systems, that is mainly solar power, PV based power supply, and battery energy storage systems. So one by one, we will discuss about the what is conductive or wire charging. So in this table 1 provides the details of other types of conductive charging based electric vehicle charging system. So let's discuss. First one is the conductive charging is the charging the EV battery with the use of power cable or charging cable, that is the direct contact, is classified as conductive EV charging. The charger or cable will be directly in contact with the onboard charger to charge the battery in a controlled manner. Then the non-conductive, that is wireless charging system. So in non-conductive charging, the charging the battery, EV battery, without any direct contact with the vehicle. So in this, the charging takes place with the wirelessly from the charger or wireless induction pads to the receiving induction pad inside the EVs through the use of high frequency reinforcement signals in the range of kilohertz. So EVs collects the electric power contactless for their batteries from the buried high frequency power cables under the load or charging station's surface through the magnetic induction or inductive charging. So EVs that charge wirelessly are called road powered EVs or wireless EVs. So the main advantage of this type of charging is no cables required and it is safe. The disadvantage is it's slow charging, only applicable for AC charging and not for DC charging. It is costly and the placement of the wireless charging system is expensive. So from the figure, from the slide figure, shows the typical configuration of conductive, that is wire charger, and wireless non-conductive charging scenarios. So you can see the wire charger and wireless charger scenarios within this figure. Then the third one is the solar powered charging stations. So solar powered charging is another other energy sources than electricity, such as solar can also drive the EVs. So the charging process does not change from the conductive charging, but the input DC source for the onboard charger will be through solar PV modules connected directly through the cable or wires. So advantage of this solar power charging system is unidirectional power flow, that is grid to vehicle, free cost of input supply of the electricity, and the disadvantage is that it is applicable only for the DC charging and can be charged only during the daytime. So in this slide, the figure shows the basic block diagram of solar powered EV charging system, in which under the roof the few electric vehicles are parked, and with that help the vehicles are getting charged. Then the BESS, that is the battery energy storage system. So in this, the electrical energy is stored in the form of battery or a group of batteries depending on the electricity requirement for charging the battery, and it is a type of conductive charging. So battery energy storage system can be stored the energy from the renewable energy sources like solar, wind, etc., and also supply energy during the nighttime or non-solar periods. So advantage of this battery energy storage system, a powered charging is a clean energy sources and can deliver power during both day and night times. And the disadvantage are high upfront cost and large size of requirements are required. So from the slide figure shows the basic block diagram of battery energy storage system, powered EV charging system. So the battery energy system can be also be used for while vehicle to grid power flow occurs with additional use of DC to DC converters. Then the battery swapping stations. So as we already know, this is the special case of charging batteries where the discharged batteries is replaced with fully charged batteries, usually by automation or robots or by manual instead of charging the batteries at electric vehicle charging stations. The the advantage of this battery storage system, battery swapping system are fast charging time, easy process, and longer battery life due to the optimized slow charging. And the disadvantages are additional battery cost and expensive battery swapping system. So use of automated system can cause expensive for the battery swapping system. So in general, the battery storage system is applied for two-wheelers and three-wheelers EVs, as the battery weights are less compared to the four-wheeler batteries. Then the pantograph charging. So it is a type of conductive charging which is used for charging the batteries of heavy duty EVs such as e-buses, e-trucks, etc., like in trams and trains. So the charging is only from the EVs having the batteries located at the top. The benefits of this pantograph charging are fast charging with wide range of power levels, less charging time, then fully automated and robust design is there. And the disadvantages are high upfront cost, applicable only for the DC charging, and high power charging, and applicable only for the heavy duty EVs. Then the smart charging. When any of the charging technologies uses the intelligent software, the Internet of Things, IoTs, 5G technology, fully automated system, or use of robots, then Android or mobile based control, etc., then such type of charging can be classified as a smart charging. So from the figure you can see the user is setuping the is implementing the vehicle for his charging equipment, and he is charging the vehicle, and he is noting the SOC level and making the reminder to his cluster into his application. After getting the fully 100% SOC, he will get the alertness and message from the EV, and charging will get cut off from the charging grid, and there will be no excess power consumption to this charging vehicle. So all this can be controlled with the help of cloud connectivity and with the help of IoT real-time diagnosis. Then electric vehicle charging stations for different levels of charging. So it is well known that in India and most of the other countries in the world, the electric power supply voltage AC is a standard 230 volt per phase, that is 400 volt line to line, with a frequency of 50 hertz. But in certain countries like US, Canada, South Korea, Japan, etc., the supply voltage is just 120 volt per phase with a frequency of 60 hertz. So the voltage and frequency difference in certain parts of the world allows the manufacturers of the electric vehicle charging stations to manufacture them according to the grid requirements of respective country. So there are four levels of charging EVs from electric vehicle charging stations, that is level 1, level 2, DC charging, and superchargers. So the brief details on different levels of charging are explained in detail in next slide. So level 1, that is also called as an onboard charger, and level 2, onboard charger. So level 1 onboard charger, it is applicable only for the countries with 120 volt 60 hertz grid systems. The maximum current capacity is 12 ampere or 15 ampere per phase, and has a power level from 1.44 to 1.92 kilowatt. So it does not apply to the India, as the nominal voltage range for the Indian grid is 220 to 240 volt AC. with the frequency of 50 hertz. So charging time is nearly 20 hours, and the advantage of level 1 chargers are low capital cost, low impact on peak demand loads charges, and the disadvantage is obviously it is a low charging process. Then the level 2, that is the onboard charger. So this type of charging has voltage of 240 volt per phase with a current capacity of 80 ampere maximum and power levels rating from 19.2 to 22 kilowatt. So India is currently using this level of charging, and it is considered as a slow or a normal charging and used in home charging and few as public charging stations. So charging time is nearly about 8 hours. The advantage of these level 2 chargers are a faster charging time and more energy efficient compared to level 1 chargers. And the disadvantage are costlier than level 1 chargers, and there is high impact on the peak load demand charges. Then the next one is the DC charging, off-board charger. So this type of charging is through DC voltage ranging from 50 volt to 1500 volt DC, and maximum current capacity ranges from 80 ampere to 400 ampere or higher. So the powerful level shall be in the range of 48 to 400 kilowatt or higher. So this type of charger is also called as a DC fast chargers, and it is generally preferred to be used in a public charging stations. So the charging time, it is approximately just 30 minutes. This depends upon the battery capacity and its state of charge for given charge power level. The advantages are high charging power, faster charging compared to the level 1 and level 2 chargers, and the disadvantages are more expensive, increased load peaks, complexity of standards, additional safety and security requirements are needed, and cause problems with the EVs are operated in the cold weather conditions. So you can see the what differentiate the level 2 AC and DC fast charging. Then it comes with the superchargers, that is the off-board chargers. So they are also called as a Tesla superchargers, as it is applies only to the Tesla EVs manufactured by the company Tesla. So the charger both the versions of voltage levels, that is 120 volt, 240 volt, or 400 volt, or higher than that. So the power capacity ranges from 120 kilowatt and up to level of 250 kilowatt. Superchargers are also called as a DC fast chargers. The charging time is approximately 20 minutes. So this depends upon the battery capacity and its SOC for a given charge power level. So the advantage of this extremely fast chargers and is the extremely fast charger as compared to level 1, level 2, and DC charging. And the disadvantage are it is unique in design, not in common. Only the Tesla EVs can be charged on these particular chargers. Then the charging levels. So level 1 and level 2 type of charging is only for the AC power transfer, whereas DC chargers and superchargers are only based on DC based, and it is a fast charger having less time to charge the batteries present in the EVs. Sometimes DC charging is also called as a level 3 chargers, and Tesla chargers are also called as a level 4 chargers. And by going up the levels, we can observe the decrease in the charging time, right, by an increase in the current capacity. Then electric vehicle charging stations, different types of connectors, guns should be used and are used. So connector guns for each charging type are manufactured separately to accommodate different voltage, power, and current levels. So connector guns are connecting cable between electric vehicle charging stations and electric vehicle that transfer the energy from electric vehicle charging stations to EV. A comprehensive understanding of these connector guns available around the world is required. So there are a total 11 types of connection guns worldwide. That is 6 connector guns for AC and 5 connector guns for DC. So figure shows the different types of connector guns that are available worldwide. Due to the different design aspects in each country for the use of connector guns for the charging process, there are total of 4 types of charging methods or protocols worldwide that are currently used in the existing EVs and electric vehicle charging stations for the charging process. So the charging methodologies are charge demo, that is called as a CHAdeMO, then combined charging system, that is CCS, then GOBO, that is GBT, and Tesla. The country of the origin of these charging methodologies is from Japan, Europe, China, and United States for CHAdeMO, CCS, GBT, and Tesla, respectively. Then existing charging guns with their specifications. So table 2, you can see, provides the details on ratings of the connector guns and their capacities. So type 1 AC connector gun, plug of charging connect charging gun or EV plug is used for single phase charging up to voltage of level of 250 volt AC, charging the current up to 32 ampere and power level up to 6.6 kilowatt. This type of charging guns was used only in the US states and Japan during the early 2010, which takes 4 to 6 hours to charge the battery to 100% capacity. Then the type 1 AC connector is also known as a SAE J1772 connector. So now the type 1 AC is replaced with the new connector guns, that is CCS type 1 for AC and DC, similar to the old version of type 1 connector guns, but are having compatibility for AC and DC charging is up to 32 and 80 ampere respectively. So similarly, CCS type 2 AC and DC charging gun, which was proposed by German manufacturer, that enables both single phase and 3-phase AC charging and DC charging in a single charging gun. So the voltage level for this AC and DC charging are up to 480 and 1000 volt respectively. The current capability for AC and DC charging is 63 ampere per phase and 400 ampere respectively. So then the Tesla AC or DC charging guns are exclusively for the Tesla EVs, having similar configuration for charging guns, combined charging stations, type 2 AC and DC, but it is slightly modified in terms of contact pins size, which will not fit into the CCS type 2 EV plugs. So CHAdeMO charging guns are introduced in Japan initially and then spread across the globe. So this type of charging gun is used only for DC charging. There are versions of CHAdeMO specification, that is version 1, 1.1, 1.2, 2, 3, and further in the future it is going to be a 3. So the current version which is implemented and it is used is the CHAdeMO 2.0 specification, which allows for the voltage level up to 1000 volt DC and charging current levels up to 400 ampere, that is 400 kilowatt. So China has introduced its charging standard under GBT, and which are the GBT AC and DC. Unlikely CCS type 2, that is AC and DC, GBT AC and DC uses separately charging guns for AC and DC charging. Then GBT voltage levels for AC and DC chargings are up to 480 and 950 volt respectively. So GBT charging current levels for AC and DC charging is up to 32 and 250 ampere respectively. So having said about all these types of charging guns available in the world and their application is in respect to countries, India has its type of charging guns, but the specification are mostly adopted from the specification of GBT AC and DC charging guns. So these charging guns are called as a Bharat AC charger, that is AC001, and Bharat DC charger, that is DC001. The major difference is GBT AC and DC and Bharat charger AC001 and DC001 is it is the voltage, power, and temperature levels. So the DC voltage levels for the charging the batteries are limited to 48 volt, 72 volt, 100 volt, 120 volt respectively. So the power levels in AC and DC charging is limited to 10 kilowatt, that is 3 charging guns with each of the 3.3 kilowatts, and 15 to 20 kilowatt, that is one charging gun with 15 kilowatt or two charging guns with each 10 kilowatt respectively. So the ambient temperature range of this GBT EV plug is from -30 to 50 degrees Celsius, whereas for AC001 and or DC001, EV plug has an ambient temperature range from 0 to 55 degrees Celsius. So shortly, it is also expected by the Bharat charger to release a new version of AC charger called AC002, which will be used to cater to a higher power like 6.6, 13, and 20, 21 kilowatt. Going forward, India needs to adopt and would make it mandatory for charging guns in each charging stations for combined charging station type 2 AC and DC, as 90% of the major manufacturer out of 12 uses CCS protocol and uses CCS type 2 AC and DC charging voltage, so up to 1000 volt, current up to 400 ampere, and high power up to 400 kilowatt DC power transfer using a single connector, including AC power, is possible using the less space and charging guns. So CHAdeMO provides the voltage level up to 500 volt and the current up to 125 ampere, and GBT has a separate connectors for AC and DC charging, which can be used only up to 250 amperes. Then the overview of the charging standards. So standardization before the year 2010, only a few aspects of charging processes were there, like detection of power for charging and sleep mode in the absence of charging power. So this process was framed in the international standard IEC. That is, since 2008, the process of standardization has been intensified and address aspects of connector guns, EV plugs, security mechanism, PWM protocol, and communication. Then broadly, the major standards making organization across the globe are divided into 5 groups, that is IEEE standards, SAE standards, UL standards, ISO standards, IEC standards, then DIN standards, GBT standards, and Indian standards, international standards, that is IS standards. Other standards making organization include EN, that is European standards, BIS, that is British standards, and SFS, that is the Finnish standards. As of July 2020, there are many testing standards of electric vehicle charging stations that are and will be adopted in India and other countries. So with the evolving nature of these EV and electric vehicle charging stations, the testing standards are also evolving, being created and changing each year since 2018. So India will adopt all these standards prepared by all the major standard making bodies, but will mainly use IES, ISO, and IS standards. The main IES standard related to electric vehicle charging station is IEC 61851, which is managed by IEC TC69. So major existing international standards for electric vehicle charging stations. So the major and more relevant international standards have been provided in the table. So in this IEC standards stands for International Electrotechnical Commission, which is headquartered in Geneva, Switzerland, and it is the organization that prepares and publishes the international standards for all electrical, electronic, and related technologies. So from this standard, international standard, you can see how the IES standards are split and what application are uh, recognized for these particular standards. Then the main standard for electric vehicle charging stations, that is IS ICE 61851, this standard document. So under IEC standard 61851 document, there are three types of cases for the physical connection between EV and EV charging stations using charging guns or EV plugs, which is shown in the figure. So you can see in the case A, the cable and the plug are attached to the EV. In case A1, the cable from the EV is directly attached to the electric vehicle charging stations without any protection like a domestic or home charging using a wall mount charger. But in case A2, the cable of EV is connected to the electric vehicle charging station through a protective device installed in electric vehicle charging stations like in public charging. Then case B, you can see in case B, the cable is detachable at both ends. So EV and electric vehicle charging station sides, which is portable. The cable can be portable from both the sides. So in case B1, the cable connects to a standard domestic plug. In case B2, the cable connects to the specific charging station. In case C, the cable is attached or it is fixed to the electric vehicle charging stations. So this type of connection is generally used in the public electric vehicle charging stations. Then IEC several charging modes. So IEC also has a several charging modes. This nomenclature is now used by all electric vehicle charging stations manufacturer. So mode 1 and mode 2 uses a standard 16 ampere and 32 ampere socket outlet, both single and three phase respectively, wherein mode 1 is not used widely and not accepted by the United States for their EVs. Like mode 1 and mode 2 is widely adopted across the globe sometimes and uses a specific plug that includes the protection mechanism to detect leakage current through the control pilot wire. So the cable used for the mode 2 also provides in-cable residual current device, over current protection, over temperature protection, and protection in earth detection. Both these modes fall under the category of low power AC charging systems having the power capacity of less than 22 kilowatt. Then the mode 3, you can see the required a dedicated electric vehicle charging stations cable wherein a control pilot charging process is controlled by electric vehicle charging stations. Mode 3 is a widely used and recommended way of charging, and it is also safer than mode 1 or 2 because the EV cable is powered only if the below requirement are met. The vehicle power plug is inserted, that is the pilot pin is the last to contact, and then the ground continuity has been checked. Then the vehicle has transmitted a signal confirming that everything is secured and charging is ready to begin. Like mode 1 and mode 2 and mode 3 is also type of AC charging, but with the extra current handling capacity greater than 32 ampere. So including 16 ampere, 32 ampere, it can handle. So thereby having a power capacity even greater than 22 kilowatt. Mode 4 charging is a DC charging having a current handling capacity greater than 32 ampere. So power capacity of this mode 4 is generally 50 kilowatt and higher. So mode 4 covers the inverse charging process, which is vehicle to grid power flow, that is EV providing power back to electric vehicle charging stations. High level communication over control pilot circuit is required for bidirectional power flow, and communications. So figure shows the different modes of the charging levels. Then the status of Indian standards for electric vehicle charging stations. So with the motive of increasing the adaptation of EVs, innovation, and infrastructure to charge the EVs is also developing in the country. So in India, public sector like NTPC, EESL, BHEL, etc. have taken lead in installing the electric charging stations in various parts of the country, from which electric vehicles can plug into it and charge their batteries. So the Committee of Electro-Technical Division, that is ETD 51, which is set up by the Bureau of Indian Standards (BIS), is mainly responsible for the preparation of Indian standards for electric vehicles charging stations. So IES and ISO committee originally prepared the IEC and ISO standards respectively for electric vehicle charging stations. So that is IEC 61851 and ISO 15118 series of standards, while the IS 17017 series of standards are the main standards for India that set the requirement for electric vehicles charging stations and related equipment. So the IS 17017 series of standards are derived and adopted, not all equivalent, from the IES 61851 series of standards. The ISO 15118 series of the standards are directly adopted, made equivalent to ISO 15118 series of standards for India. So apart from BIS, the Department of Heavy Industries and Automotive Industries standards have prepared and published relevant standards for EVs and electric vehicles charging stations. So DH has released the Bharat Charger AC001 for AC charging and DC001 for DC charging system in the year 2017. So which was adapted for GBT, that is Chinese standards, with slight modification in ambient temperature relevant to Indian climatic condition. The replaced ambient temperature range was 0 to 55 degrees Celsius. AIS has released the standards for AIS 138, AIS 138-2, etc. for testing of electric vehicle charging stations, which was adopted for the IEC 61851 series. Then CEA regulations released by Central Electricity Authority, Government of India in 2019 on measures relating to safety and electric supply and technical standards for connectivity to the grid, lies out the requirement of voltage changes, frequency variation, power factor, harmonics measurements, flickers, DC injections, vehicle to grid process, and safety of the electric vehicle charging stations. Then the electric vehicle charging station standards for the Bureau of India standards, that is the BIS for India. So table 4 provides the complete list of electric vehicle charging station standards used in India, prepared mainly by BIS. In this, EMC stands for electromagnetic compatibility. So you can see the IS 1701 17, that is EMC required for off-board DC EVs. Then the section requirement for the control communication between DC, EVC, and EV. Then standards for the plugs, socket outlets, vehicle couplers, and vehicle inlets. Then the standard for the exclusively for light vehicles consisting of 7 sections. So these standards will be adopted for IEC 618513 series. This standard is not published yet. So EMC testing for emission, immunity, and harmonic testing. So all these standards are taken care by the BIS. Then status of Indian standard for electric vehicle charging stations. So figure 8 shows you the status of IS standards for electric vehicle charging stations in India with respect to other similar standards from Europe, that is IEC, China GBT, Japan CHAdeMO, Germany DIN, North America SCE and Tesla, and ISO standards. So first of all, it should be noted that the ISO standards are only used for communication and EMC requirements for electric vehicle charging stations. So the standard requirement for the system performance and the type of EV plug use are common for countries like US, Japan, Europe, Germany, China, and India. The requirement mentioned in the standard like IEC 61851, GBT 18487, and IS 17017-1 are equivalent. Similarly, the standard IEC 61851-3, GBT 18487.3, and IS 17017-23 are also equivalent. So only the standard number varies for each countries. For the type of EV connector used, the standards IEC 62196 and 62196-3 provide the requirements and are equivalent to GBT 202341. So respectively, so the requirement mentioned in the IEC 62196 and GBT 2031 and IS 17017 standards are the same. So similarly, the requirement specified in IES 62196-2, JBT 20341 and IS 1707 are also the same. Secondly, the communication requirement of electric vehicle charging stations for all the countries except Germany and Japan are common, and they are as per the ISO 15118 series of standard, which are adopted directly. So by IEC, JBT, and the IS standards for countries like United States, Europe, and China, and India with the different standard numbers. Germany and Japan use DIN 70121 and CHAdeMO standard respectively for their communication requirement in electric vehicle charging stations. So these standards, the standard IES 61851 and JBT is 27930 and IS 17071 are equivalent, and the ISO 15118 series of standards provide the general requirement that are common to all the countries. Thirdly, the EMC. So EMC provides the requirement both in IEC and the IEC 61851. India's IS 1701 standard and IS 1701721 standard are equivalent to IEC 61851 standards. So lastly, the Tesla EVC electric vehicle charging station does not have separate standard for their compliance. Instead, they have to compile with the requirements of the appropriate standard in respective countries. Then the requirements for the setting up of an electric vehicle charging stations with combination of EV charger in India. So from the slide, figure 9 shows you provides the requirement stated in the guidelines for setting up an electric vehicle charging stations with a combination of EV chargers in India as released by the Ministry of Power, Government of India. It can be observed that the charging stations shall have one or more types of chargers, that is the connector guns, depending on the type and the voltage level. Also, for the long range EVs, fast chargers shall have two chargers of minimum 100 kilowatt rating, that is 200 to 750 volt or higher, with CCS or CHAdeMO or any other fast charger approved by BIS. It can be observed that clearly that the use of CCS type 2 and CHAdeMO for the fast charging electric vehicle charging stations and Bharat AC 001 for slow charging electric charging is promoted in India. For public charging standards for India, CCS methodology is adopted as minimum criteria for charging stations, and in Indian market is also open to adopt adopting any other standards as well. So the same is also promoted in the FEM2 scheme of the Department of Heavy Industries, Government of India. It was also recommended by the DIHA, Department of Heavy Industry, to adopt CCS combo type 2 for fast charging of four-wheelers, EVs, and CHAdeMO for heavy duty EVs. Then the major charging methodologies. So there are four prominent charging methodologies adopted for various EVs based on connector type and digital charging communication protocols used. That is Bharat EV Charger, CCS, then GBT and CHAdeMO. The major reason and advantage of using CCS2 and CHAdeMO methodologies for India are as follow. That is, the power capacity is highest and can support up to 350 kilowatt of CCS and 400 kilowatt of CHAdeMO. The combined charging methodology can support both AC and DC charging types. Then CE has a mandated the adaptation and support for CCS methodology. Then CHAdeMO supports vehicle to grid functionality. Single connector and less space is required for CCS type 2 connector. Large manufacturers have adopted the CCS methodology worldwide and in India also. So in Europe, electric vehicle charging manufacturers are moving towards the CCS methodology, with several automakers supporting this. More and more makers in the United States and Korea are adopting CCS methodology, while Japan is also following CHAdeMO methodology and China is following the GBT methodology. So CCS and CHAdeMO methodologies are followed worldwide, with GBT is followed only in China. For India, with the present policy to accept all the types of charging protocols like CHAdeMO, GBT, and CCS, the adaptation rate of EVs will be slower when compared to the specific implementation of charging protocol, with a lot of advantages with CCS methodology, that is single connector, both AC and DC, high voltage and current and power capacity, less space, and common manufacture by major manufacturers. It is therefore recommended to use CCS charging methodology for India, which will cater to the market in India as well as abroad and help in faster adaptation of EVs. Apart from the grid power AC or DC electric charging vehicles, India needs to go for the solar power charging stations and battery power charging stations for the increase in the energy security. The energy stored by the battery power electric vehicle charging stations is in combination with grid connected solar inverters can, in addition to various grid support functions and protects the major, help the support to the grid at night and supply it with the electricity. So what are the challenges and on the standardization right now? So the challenges of EVs and charging station is a complex matter due to the involvement of two sectors, that is automotive and electrical. So in general, international standardization of which is dealt with the international bodies like such as IEC and ISO, while the automakers have a traditional been vertical integrated and less dependent on external suppliers and standards. The electrotechnical world has a longer and stronger tradition of standardization, with IEC being founded in the first decade of the 20th century. Due to the different cultural approach to the standardization in these two different technological sectors, an agreement had to be created on the division of work with vehicle centric aspects. On the road hand, on the one hand are the dealt with the ISO and infrastructure related aspects, and electrical components are dealt with the IEC on the other hand. So there are few challenges faced on the standardization of electric vehicle charging stations globally. 7 collaborative focus areas are required to build a charging systems that is better, convenient, confident, and secure, which are described as follow. That is the multiple standards for testing and certification, certifying the electric vehicle charging stations, multiple charging methodologies, multiple network service providers, then vehicle to grid interoperability, lack of homogeneity in tariff, lack of inadequate number of electric charging stations, and battery swapping systems. So four pillars of standardization you can see. With all standardization issues, the charging standard encompasses with the four main pillars, that is electrical safety, charging function and performance, and EMC compliance and digital communication protocol, that is interoperability. So figure shows the four main pillars of standardization. Standards are the key factor in the global use of EVs, and the examples of the EV is an ideal showcase to highlight the technical and social relevance of the standardization. So finally, what is the conclusion on this? So with the automobile world looking for the faster adaptation of EVs, it is imperative to test the EVs and electric vehicle charging station to ensure their quality, safety, performance, and reliability. So this session investigates the different types of charging methodology, connector guns, testing standards, and their comparison with the regard to electric vehicle standards on global and Indian levels. Then the slides also highlights key challenges in the standardization of electric vehicle charging station worldwide and provides the current status of Indian standards with respect to international standards. So the Indian standards, along with the guideline issued by the Ministry of Power, Government of India, and DHI specification of battery electric vehicles, majorly promotes the CCS methodology for EV charging and CHAdeMO 2.0 methodology for high power and fast charging. So CHAdeMO 3.0 methodology is not yet commercialized in the EV market across the globe, and CHAdeMO is the only methodology with vehicle to grid ready charging functionality that can be help utility grid during the peak load demand by providing the power to the grid from the EV batteries with the help of bidirectional electrical charging stations and EV batteries acting as an energy storage equipment. So for India, with the present policy to accept all types of charging protocols like CHAdeMO, JBT, and CCS, the adaptation rate of EVs will be slower when compared to the specific implementation of charging protocol. With a lot of advantages with CCS methodology like single connector, both AC and DC, high voltage, current and power capacity, less space, and common manufacture by the major manufacturers. So it is recommended to use CCS charging methodology for India, which will cater to market in India as well as abroad, and will help the faster adaptation and also help to promote a Make in India initiatives of the country. So apart from the grid power, AC and DC electric vehicle charging stations, the use of solar power charging stations, that is renewable EV charging, and the battery storage energy systems is recommended for the energy security of the country and reduces the well-to-wheel greenhouse gas emissions. International and national standards for measuring the energy and power efficiency performance of electric vehicle charging stations are essential to be prepared and shall be used for evaluating the EV charging stations performance to control the quality in the EV industry, as there are no such standards at present. So India is already in the process of making standards through BIS for all categories of EV charging stations, where some of the standards are already published and are currently in use. So there is a need of more charging station manufacturer to be installed in the system in all parts of India, that is urban and rural, for the faster adaptations of EVs with the increasing use of vehicle to grid, smart electric charging stations, and IoT based communication between EVs and charging stations. There could soon be a cyber security issues that need to be addressed and to avoid the problems related to the hacking. So all these concepts we studied in detail, and what are the conclusions we had we had discussed in more detail. So here is what all about the standards for charging stations in India and globally. So these are new concepts and new topics for you. So in detail, you go through this in free time, and I will share these slides with you. Hopefully, you understand all these standards and adaptations for EV charging stations.
Thank you, Harshal sir, for such a detailed elaboration about standards of electric charging stations. What is the global scenario for electric vehicle in the world as well as in India? How the developments are happening. Uh, I
Yeah,
really
what
thank.
kind of a connectors and
Yes,
how the electric grid systems should be there, how much current, how much voltage compatibilities are there. All that levels has to be categorized, and as per the various frequency of electricity in India or in globally, as per that it should be standardized for all the EVs. The connector should be standardized for all the EVs.
correct, sir. So actually, we are very lucky that you have gathered all such a information, vast piece of information, which is essence of your experience as well of your professional learning, whatever you are doing right now. So
And
our students are very much fortunate to hear it from you. If
no,
any,
as EV is the emerging field, and there are a lot of aspects in energy storage system, battery storage system, battery swapping systems, and safety regarding. So all that has to be taken into mind. So we are also learning, and from our learning, learning is just sharing the knowledge. So I'm also fortunate that I'm sharing these details with you guys, and you are luckily aware about these topics in early stage, because in future you will get a lot of understanding about these concepts, these standards, and what are these level 1, level 2, what are these standards for globally, for international, for Indian standards compatibility. So all that details you will also get more curiosity to learn.
yes, sir. A few days back, I would like to tell you an incident. A few days back, we have a session from an expert from Tata Technologies. He was
Okay.
saying that they are mainly interested into the students who are having in-depth knowledge of electric vehicle. So they are working
Okay.
on various projects related to electric vehicle. So as a part of a Sanjeevani College of Engineering, we have given this platform to our students to explore this new technology and work on that particular technology, try to prove their talent, and get selected in some good companies, which actually,
Yes, yes.
if these are, as you know, that these are the skills which are highly in demand. So we always try to, or we strive to get an expert like you from industry, so that they could bless our students with their knowledge and their experience.
No, obviously it is very much initiative the directors and your faculty members have taken, because I found this EV structure only in few colleges has taken the initiative for EV technology. So students are getting more awareness about this EV platform in early stage. So while going to their placement, they will have a little bit basic understanding of EV nomenclature, terminology, which is not available in our Pune University BTech students.
Yes,
So yeah, so this awareness, and they should take the benefits of that. They should give the interviews for the upcoming technology, future technologies, those who are hiring for electric vehicle conversions and all. So it will be more advantageous for their growth in career.
yes, sir, definitely. Actually, there are many students who has already been selected. Like there was one organization like JNK Private Limited. This
Yeah, yeah.
particular company was majorly into
Fuel cell.
fuel cell technology. So they are
Yes.
working on fuel cell technology. So while selecting the students, they have selected specifically those students who has got a good technical knowledge on the alternative technologies. Like for an alternative technology, that means electric vehicle. So there are 2 students from our electric vehicle batch has got selected to this particular company. So that
Yeah,
was
yeah.
it was a major contributor for their interview. So I hope that most of the students who has missed today's lecture will get the essence of this lecture by recorded sessions. And
Yeah.
all of you, please note that your question paper will be based on the things which are discussed in this particular recorded sessions. So I hope most of you will be making most of it. And thank you. I think it's too late now, sir. You have
Yeah, yeah. We will wrap up now, and
yes.
I'm
I
really
think-
thankful. I'm thankful for all the students, those who were patiently attending for these sessions. And it was a lengthy sessions today, but a lot of concepts are there which you must be not understanding. But I try to simplify it on my slides and get it presented in front of you. So in free time, don't just skip it. Just go through the standards and go into all the details, so that you will get more understanding about this particular standardization process.
Yes, sir. With your permission, shall I end this sessions for the day?
Yeah, yeah, yeah. Sure, sure, sure.
Okay. Thank you,
Thank
Arshad,
you so
sir. You
much.
have given your precious 6 hours today, and I know
Yeah,
that
not an issue, sir.
it might be a very hectic day for you to speak for 6 hours.
No, sir. Actually, the environment in Bangalore is also a little bit uh, crucial now, because it's raining outside. So instead of spending idle time, I can share my knowledge with you guys. So that is the most beneficial idea for me.
Okay, sir. Thank you.
Okay,
Thank
sir.
you, all of you.
Thank you so much, guys. Yeah.
Thank
Bye.
you. Thank you. Thank you, Shiv
Thank
Kumar,
you,
for
sir.
arranging this session.
Thank you so much. Yeah.